Hi everyone, my name is Zhenglin Wang, and today I want to show you guys one project I did last semester. I also showed this project in one of the M&A conference in Sacred Heart University, and definitely it will be a part of undergraduate final thesis. So the theme is a noise-resistant k-nearest neighbors classification. So let's talk about the original k-NN first. It's a kind of non-parametric supervised learning method, and usually we choose k between 1 and the sample size, and definitely it's an integer. So there is a very simple visualization. So when k change from 3 to 6 to 9, the final decision based on that current point classified as blue and to yellow and to blue again. So which means that the k changes a lot for the final decision. So which means k definitely is a very important hyperparameter in this context. So the first question come out, how to choose k? So there is a data set, it's a chronic kidney disease with some features and classes. So usually based on the hyperparameter tuning, we usually like to choose the highest accuracy associated with that k. That is called an optimal k. But in real-world application, especially for the medical data, if especially there is some natural variance, also sometimes we call noise inside of data, the best choice of the optimal k is not good. So usually we would like to define a new things, we call it as a reasonable k. So we define the reasonable k as the critical points of k is called k crit. So in this example or the plot, we zoom out a little bit to find how to find the critical point of k. So we first draw a horizontal line respect to the first accuracy, and then we find the intersection. It's called k0. So then we find the mean or the average of all the accuracy above that horizontal line and find the closest k associated with that average accuracy and call it critical point of k. So that definitely would be a reasonable choice. And after the aggregation with different seeds, we get the final critical point of k in this data set, it's 62. So then the main character come out, the artificial noise. What if we include some uniform noise in this case? So we plot the accuracy versus noise numbers, and we find that when noise increases, the accuracy drop, which means that original KN is not good, deal with the noise. So I introduced a new method. It's called reliability weighted all neighbors. In short, is RWAN. So there's new terminology, it's called reliability. So I define it as 1 over 1 plus the Euclidean distance between the point and its within class centroid. The range of the reliability is between 0 and 1, and you definitely can change the 1 in the denominator to change the upper bound of the reliability. And for the visualization, you will find that if the point is close to its associated with centroid, so the reliability of that point is high. If the point is far from with that centroid, sometimes the reliability is low. So then we can define our RWN. It's a kind of classifier utilize all training points and assign each of them a reliability to get their associated weight. So the weight formula is the reliability over the Euclidean distance between that point and the new current point. So the new current point is some point we want to classify. So instead of the majority vote as a original KM, we want to define a score. So we'll vote as a score and vote the maximum score. So we define the score as the sum of all weights within each class and divide by that subsample class size. So that would definitely be a very reasonable choice and classification method. So what's changed? For the original KN, in this example, it will classify as blue. But for RWN, it will classify always as the yellow. And which does make sense because the red point is close to the entity of the yellow point. And what if artificial noise included? When noise increases for the right plot, the accuracy will not drop anymore. But the initial accuracy is a little bit low. So it's a kind of trade-off between the accuracy and the noise robustness. So the next thing is we want to deal with the hidden parameter to deal with that trade-off. So that's everything about the current project. Thanks so much.